Oh, hi. Toasting bread. It does take a while, doesn't it? Even though this may have been overcooked. But the point is, we're going to solve this problem by building a 10,000 watt toaster. Alrighty, with all projects where I modify something, I start by figuring out how the appliance usually works to get an idea on how we can modify it to our needs. Before I even had opened the toaster, I found my first obstacle. This screw. Like, who are so afraid that some regular dude would mess around with their toaster that they would have to use these tri-wing screws or whatever? I don't have the tools for that. Which is the whole idea, I know, but hey, I got him out by using this Torx 10 screwdriver, so yeah, off you go. With all those screws out of the way, I had to take off this toaster lever thingy to be able to take off the cover. Yeah, just like that, it just fell off. After looking inside the toaster for a bit, I found that this one is the heating element, obviously, and this is the electromagnet holding down the toaster lever when active. And we would definitely want to reuse that part. This toaster is roughly 700 watts based on the resistance I'm measuring. And thinking of it, how are we going to get 10,000 watts in this thing without modifying it too much, because I'd like it to look as much like a toaster as possible. But we'll have to see about that when we start building the heating elements. Just look, even past me have no idea on how to build this thing. Alright, first step out of the way, we know how it works. Now we're just gonna get those all heating elements out of the toaster to modify them. There's a total of 3 elements and they're all connected in series, which isn't really important as we're not gonna be using those elements. So I think I have a plan on how we're going to modify this thing, based on how I think this thing works. So we have our 3 original elements, which we need to modify to have a total effect of 10,000 watts. So this is the plan. That's a cute drawing for the toaster. I'm not much of an artist, but yeah. Point is, we have these 3 elements, which have a total effect of 700 watts, but we want 10,000. So I calculated that we would need at least 5 additional elements, and each of those elements need to be at least 26 ohms. That way each element is slightly above 2000 watts. And I'm planning to put 1 element on each side of the, what do you call it, the bread, slice of bread, and 3 elements in the middle. So we have the most amount of heat in the middle. So yeah, 6000 watts between the slices of bread, that's quite a lot, isn't it? But for now, I'm gonna wait for the resistance wire to arrive in the mail. Right, so if I were correct when I did the calculations before I ordered these wires, each roll should be 26 ohms and therefore 2034 watts. Yeah, I need something that can handle a lot of heat and doesn't conduct electricity. The only thing I can come up with is these toaster elements. I'm just going to do an initial test to see if we actually have 2000 watt in this thing. Because if we don't, this wouldn't be a real 10,000 watt toaster, and that'd be really disappointing. But before I start finding a way to install all the 50 meters of resistance wire in the toaster, I wanted to see if a 0.81mm wire could handle the current it would be passing through without melting. Because if it melts, we're gonna get the same problem we got with the 10,000 watt kettle version 1. It just didn't work. But I do have an idea. I just wrapped the whole thing around this to make spring coils or whatever, like these. That can make it better. So yeah, this is the basic, this is the first element. And I'm gonna be having 3 of these. This is just 2000 watts. One of these is gonna be 6000. That's gonna be interesting to make. But first off, we're gonna see if this actually works. For dramatic effect, I'm gonna turn off the lights. Ta-da! Okay. You know, just in case. Okay. Great! Uh-oh. Ah! Stop! Oh! Problem is, if these touches, they would get even hotter. It's gonna be so hard to create this without any of the elements touching each other. Okay, shorted somewhere again. Yeah. Oh, okay, I gotta fix this problem because we can't risk melting the elements, because if we do, as I said, we got a problem. So, fix. Okay, after some testing, and yeah, don't judge me on my testing rig, it's really hard to insulate something that becomes 1,000 degrees, okay? So what I figured out, I confirmed that we could push each element over a longer period of time without them melting, which is what I wanted to check. Now I just had to make sure the elements would touch each other, which you saw previously, as that would make them much hotter and eventually melt them, which isn't great. And you may be wondering, why am I going to use 5 elements when I only had 3 plates inside of the toaster? Well, the answer is really simple. Finding just the right type of nickel wire with the right size and ohm per meter was so hard. So to reach our glorious goal of 10,000 watts, 5 elements and 50 meters of wire was the best I could do. Going further, I had to check what voltage the electromagnet was supposed to work at, so I took it out and did a test at 12 volts to begin with, but 5 minutes later I decided to go with 24 volts instead, which worked better and didn't break the electromagnet. Now, I don't have the equipment to fabricate steel parts, nor do I have materials to insulate really high temperatures. So after some thinking, and I know this is gonna sound ridiculous, I'm gonna build a toaster out of wood. And before you start screaming, oh, it's gonna catch on fire, I will say you're most likely right. But I'm using this bitumen membrane. I have never heard of that word before, but that's what it said. Anyways, I'm using the bitumen membrane as heat shield and hopefully would be able to make one toast at least. But there might be some fumes from this material when it's hot. I don't really know. I just figured that the toaster wouldn't be active more than 20 seconds anyways, as the toast would probably be well done by then. By the way, I'm completely aware that these screws are not insulated and would get electrified. Now, with that said, I'm probably gonna piss off a lot of electricians or people that know how electricity works, and all of you are probably gonna say you shouldn't do this. And you know what? You're absolutely right. Oh, hi! Yeah, don't mind all the mess. I've been doing some stuff. More specifically, I've been making this. Okay, so what I've done really is putting it together. Remove this part of the plate, so more heat would reach the bread. And also put in a stronger spring into the toaster, so now I'll make sure that the toast will come flying out. Oh. But I still had all of the wiring to take care of, and I had to find a way to connect all these 13 wires together in a secure way. And for that problem, I used this big terminal box, which could handle all of the wires. When all those wires were connected, I put on the 32 amp 3-phase plug that all of you have never seen before. But as I said in the kettle video, we have a different grid system here in Norway, so I don't have a neutral wire. Okay, this is the progress, you know, we're almost done, you know, but not really. You see, all you have to do to test this thing is to put live electricity on these two, and we should also ground it, of course. But the deal is, for some reason, I just want to make this more complicated for myself. So I'm going to be adding, for the controlling circuit, a microcontroller or an Arduino, as it's called. And to make it more pretty, because I don't want the Arduino and all of the buttons just, yeah, all over the place, like around this place. Like I'm probably gonna have the Arduino here and some buttons here for starting the thing. I also want to try to make a PCB. Not because I have to, like I could, as I said, just put live wires on those two wires, but that's too simple. I am making this much harder for myself. But my idea is I want to manufacture my own PCB, because I can now with that. After a lot of renovation, that's also why it's been taking so much time to get to this point. I've been taking away that, I've been doing a lot of stuff. Point is, I can manufacture my own PCBs with that thing. Okay, so I really hope I'm not gonna have to delay this video because of this. The point is, I don't know how to use this machine. I haven't designed a circuit board in 5 years, and on top of that, I gotta program the Arduino which I also haven't done in ages. I haven't programmed anything since 2022. As I said, I could do this really simple, but I really want to try to manufacture a PCB. Like when you get a new machine, like wouldn't you try to use it? Like, so we're gonna go with the hard way. I started right away designing the circuit board, but conveniently enough, this was my first time using KiCad. So I had to search up a lot of stuff to figure out how to use the software. Yay, the schematics are complete. Turns out I couldn't speedrun creating the PCB without a schematic to support the connections. But whatever. With the schematics and PCB design complete, it was time to figure out how to manufacture this with the Makera Z1. Luckily for me, this is actually really simple. First off, I installed this 90-degree angle for the material to go against, and then I cut out this small wooden rectangle to act as a sacrificial board underneath the circuit board, so when I do the cutout, it wouldn't destroy the drill bit. And then I clamped it down and then made it ready for machining. Now don't think that this machine can only create circuit boards. This thing is almost like a 3D printer, but it's for all materials and not just for plastic. You can engrave, cut out in 2D and 3D, and probably more than I know. I'm still learning what this machine actually can do. But going from not knowing anything about this machine to creating my first circuit board was surprisingly simple. It just took me a few hours going through the Makera's own wiki site to understand how I could operate this machine, which really shows how simple it is to begin using one of these machines. So this machine is highly recommended, and I will definitely get use of this in future projects. So if you consider getting a machine like this for yourself, there's an affiliate link down in the description. Whoops! Well, I messed up. That thing is meant to measure the height of the material you're working on, but I accidentally ran it straight into the 90-degree angle and bending it. And getting a new one could take weeks as I live out in nowhere, so that's why I just bent it back. Oh yeah! Okay, everything works. I know how to create the PCB file, I know how to upload the file to the Makera, I know what drill bits I need to use, so just to be on the safe side and not to waste too much material, I made a small test PCB, which is 2x2 centimeters, which went so smoothly to begin with. We're supposed to go down here and then all the way down here. It's at this point, this is where it kind of snapped because it became too much. Great. Now we should be able to do everything right. This time I was so confident that I decided to create the complete circuit board, and eventually... yeah, we finally did it. The first PCB, it's done, but it doesn't work. And I'm going to show you why. If you could see these small traces, they are a little bit broken because they were, well, too small. So yeah, this doesn't work. So it's a really simple fix, but for now I'm not gonna do that because, well, yeah, that's the time. It's almost 2 AM and I gotta wake up in 4 hours for work. So yeah, I'm gonna go to bed. And this, I'm gonna take care of this tomorrow. The next day I machined a new circuit board with traces that's 0.4mm thick instead of the 0.2mm, which was just a mess. Makera themselves don't recommend having traces that small actually, but I didn't read that before after I made that mistake. After that circuit board was done cutting, I had to manually drill all the holes, as I had broken all of my 1mm drills. But no worries, we're now ready to assemble, but when I came to the point where I was about to start soldering, I noticed that I had completely destroyed my pads when I manually drilled. So getting a good connection wasn't going to be easy, but somehow after some time I actually managed to connect all the pins. Now we could wire the whole thing, which is the last hardware step to get this thing to work. I connected up the buttons and LEDs to the Arduino, then I used this 230 volts to 24 volts converter as the power supply to the Arduino, and then I noticed I had completely forgot to add the electromagnet to my PCB design, and now I had no way of powering it. Oh my god. But I quickly fixed that by directly soldering a transistor to the digital pin on the Arduino. Then the first test didn't really work as planned, and after doing some more digging I figured this out. Oh, it's a maximum of 21 volts. Man, I just found out that all of my digital pins, which I'm using, are on this side. But yeah, they're not connected to anything. It's oh my god. Yes! It's getting 12 AM and I gotta rebuild the whole thing. The circuit board is wrong, like completely wrong. I designed everything wrong. but I did kind of get what I wanted though. I did want to try to make a PCB, which I did, but it was wrong. Okay, now everything appears to be working. So if I just plug this test cable in, this is temporary, this is more permanent for now. It's closing in on 2 a.m. and yeah, so the cable's in, and now the toaster is active. We're gonna load it up. So now it's active, the electromagnet is on. If you turn this off, the electromagnet should turn off as well. Yeah, okay. So active, and let's do 5 seconds. No. Yeah. Now, I think everything should be ready for doing this test, or toasting bread. Currently it's 5 a.m. so we got, well, I don't get the sun set behind us, but it's really early in the morning, that's for sure. And I wanted to do this outside because this is surely gonna catch on fire. So, okay, that's good. Okay, I'm gonna get the bread and turn on the power. Okay, so before the power comes on, the relay I'm using for controlling the peak contactor was designed to be wired in NO. But since the whole design got built upside down, the relay was actually connected in NC. I just didn't know it at the time, which made this happen. So that wasn't supposed to happen yet. So what happened, I triggered a ground fault because I lost power in the whole barn. There's a lot of heat here, so it worked. I gotta see the footage to verify, but okay, so at first glance I know exactly what happened here, and we're not gonna recover from this. The resistance wires, well, they get so hot that they kind of start I guess bending down, and then they touch each other, and then it gets more hot and it just gets worse. This design as it is definitely not going to work. Well, that's disappointing. That's a lot of work and dedication for something that didn't work, but then again, it was to be expected. It's made out of wood and scraps, and it's spare parts I have laying around. And the circuit board itself, it's not working as it should. The PCB is wrongly designed. The Makera works fine, but yeah, I messed this up. But then again, if many of you find this project idea interesting and still want to see a 10,000 watt toaster actually working, I'll highly consider building a new one that actually works, which is built out of metal and not wood, and have a better controlling circuit and stuff like that. But for now, this project ended here. This is a failed project, which sucks, but yeah. Even though this video didn't go as planned, thanks for watching, and in the next video I'll hopefully have something that works. I have a lot of videos in production and in the works, but they take so much time to finish. But other than that, I'm gonna go to bed.